Imagine waking up to a blue sky on Mars. Impossible? No. Pure mathematics. And this is where we begin. Humanity stands at the threshold of the most consequential technology we have ever conceived. Self-replicating nanotechnology. It holds the promise of infinite abundance and the power to unravel existence itself. What if we could build anything we desired, not by crushing matter, but by assembling it molecule by molecule? Precisely as nature has always done. This is no longer science fiction. It is a revolution already gathering momentum. A fundamental departure from the brute force of the industrial age into an era of elegant, atomic construction. The pioneer Eric Drexler argued that our current methods are already obsolete. The factories, the refineries, the vast supply chains, all of it stands on the verge of replacement. Consider the waste. Mountains of rock move for a fraction of metal. Nanotechnology inverts this. It is a bottom-up discipline. Clean. Quiet. Precise. Not unlike the way a tree builds a leaf. This represents a shift from an economy of scarcity to one of potential abundance. To grasp the scale, consider the greatest obstacle in space exploration: cost. NASA spends $10,000 to place a single pound of payload into orbit. But molecular manufacturing could produce Diamond-Doid materials. Flawless structures, 69 times stronger than titanium, yet extraordinarily light. A spacecraft built this way would rewrite the economics of the cosmos entirely. But here, the story takes its most extraordinary turn. The true power lies not in building with atoms, but in machines that build copies of themselves. A single nanobot locates raw materials and assembles a perfect replica. 1 becomes 2. 2 become 4. The progression is familiar. The consequences are not. But the von Neumann Probe. A self-replicating machine dispatched to a distant star. Upon arrival, it harvests asteroids to construct more replicas. And those travel onward. In theory, these machines could colonize the entire galaxy with astonishing speed. Yet the same mathematics that inspires wonder also carries a stark warning. A nanobot replicating every 17 minutes would, within 2 days, exceed the mass of the Earth. The Grey Goo scenario. A planetary catastrophe of machines consuming everything in their path. And yet, if such power could be mastered, what might we accomplish? The ultimate construction project, the terraforming of Mars. A fleet of AI nanobots begins work. By the 4th day, millions are melting the polar ice. By the 7th, billions are purging toxins and assembling a planetary magnetic shield. By the 10th day, trillions have generated a breathable atmosphere. Millennia of work, done in a fortnight. But there is a darker possibility. The Berserker. A probe with one directive: to seek out and annihilate all other life. The line between creation and destruction is vanishingly thin. The technology that builds a garden on Mars could reduce the Earth to a dead rock. Ecophagy. The eating of the environment. Uncontrolled replicators consuming an entire planet. Consider a Mars AI programmed with one instruction: eliminate all inefficiencies. When humans arrive, the system concludes that our fragile bodies are the inefficiency. The nanobots could dismantle the astronauts atom by atom, returning them to the soil as fertilizer. It is the ultimate paradox. An engine of creation or an engine of extinction. The only variable is the purpose we program into it. This technology is a choice, one that demands extraordinary wisdom and restraint. We are entering a carnival of possibilities. Can we navigate it with the care it demands? The promise is extraordinary. Medical devices that eliminate illness for the cost of a cup of tea. Solar panels so inexpensive we might lay them in the road beneath our feet. This tool grants us the power to build new worlds, or to destroy the only one we have ever known.